Now, yesterday's lecture, we have learned about the polar coordinate system. Can you hear me, class? Yeah?
Yes.
Thank you. Okay, we have learned about the polar coordinate system. Okay, so if you look at the diagram here, so this is a straight line, yeah? Okay, so we have the polar axis. Okay, it's just like your positive x-axis, and then the pole here, so if they are forming the angle, we call it the theta, you know, and the length here, this is the r. Now r could be positive or could be negative. If this is positive, of course it's going to this way. If negative, then that will be here, yeah, this part here. Okay, and then the theta here present the principal angle. Yeah, if we present it using the polar system, yeah, we used a square bracket with the r, okay, the length here, and then separate by comma, and then the theta, the principal angle. Okay, now we look at the relationship between the polar and Cartesian coordinate system. Okay, so if we put it together, so your x-axis here, in fact, this is your polar axis. Yeah, the origin is the pole, right? So the angle for theta r, if at point P here, point P is presented by coordinate x and y on the Cartesian plane, yeah, and here, if we want to find the x-axis equals to r cos theta, okay, y is equals to the r sine theta, okay, and then the x squared plus y squared equals to r squared, yeah, equals to r squared. Okay, if we transpose from polar to Cartesian, okay, Cartesian, so polar here is presented by r theta and a square bracket, square bracket. So we can write down the equation here, or we'll call it the formula, where your x equals to the r cos theta and your y equals to the r sine theta. Now, for example, if we are given -2 and 30 degree, yeah, -2 and 30 degree. So in order to transpose it to the polar, I mean to Cartesian, okay, this is polar to Cartesian, so means that we need the x and y, right? Okay, so the way we find x is you put in your r, which is -2, then cos theta. All right, so as we know that cos theta, the theta here is 30, so cos 30, we get square root 3 over 2. Okay, so if you simplify this, you get negative square root 3. That is for your x coordinate. Now for y, right, for y, we just put in r sine 30. Okay, so sine 30, we know that we evaluate this is equals to half, and then here we get -1. So meaning that if we transpose this from polar to Cartesian, okay, so -2, 30 degree polar, we use the square bracket, okay, and then here it means the map onto, yeah, use an arrow key here, yeah, don't use equal sign, please do not use equal sign or here. All right, so we don't use this. Right, so we use the arrow key. Okay, so they map onto the x and also y. Okay, x and y to the Cartesian coordinate. Okay, now if we can also transpose from Cartesian, okay, to polar. Okay, let's say it's given by x and y here. Okay, now firstly what we need to do is we have to sketch the point. Okay, because we want to know where the point is located. Is it in the first quadrant, second, third, or fourth? Yeah, and then after that, Okay, we use the diagram to look for R and theta. To look for the R and theta. Okay, for instance, if let's say we have -2, -3. Okay, say for example we have -2, -3, then we sketch the point. Okay, -2, -3. Okay, so that's the point. Alright, so we know that, yeah, the angle, the theta, this is the R. The theta will be from the positive x-axis until, okay, until here. Right. Now, as we know that we have to find the R. Okay, we have to find the value of R. As we know that, okay, this one is -3 here, yeah, and then this part is -2. So your R, okay, in fact, your R is equals to square root of 2 square plus 3 square. Yeah, 4 plus 9, so you get square root 13. So that is your R. And then in order to get, now here is the reference angle, right? Yeah, this is our theta. So in order to get the theta will be equals to 180 plus the reference angle. Okay, so this is the reference angle. We use the beta to present it. So reference angle will be equals to, now so we can use the arctan, yeah. So arctan, okay, opposite and the adjacent, so which is 3/2. Okay, so if you evaluate using calculator, okay, you're supposed to get 56.31 degree. All right, so your theta will be equals to 180 plus 56.31 degree, so which is, if you use calculator, 236. Okay, 0.31. Okay, now after you have done this, one more line, okay, because we have already transposed from Cartesian, our Cartesian is -2, -3, map onto the polar with the R, which is square root 13, as well as the angle, the theta, which is 236, yeah, 0.31. Okay, and use a square bracket to indicate the polar form. Okay, and we also have, if we want to transform, okay, from the Cartesian to polar equation, yeah, or equation, these are the only the point, right? Yeah, but what about if there is an equation? Okay, and I just write here. Okay, the polar equation. Okay, just remember, always remember, we use the formula, yeah, for x equals to r cos theta, and then the y will be the r sine theta, and as well as x squared plus y squared equals to r squared. Okay, now class, in fact, if you look at this x squared plus y squared equals to r squared, this is the equation of the circle, yeah. Okay, with radius r. Okay, with radius r. So this the connection here, yeah. When we calculate this, yeah. Yeah. So in your future, if you learn maths, yeah. So you can organize this easily. Yeah, this is the equation of the circle with the radius r here. Of course, the origin here, Okay, the center, sorry, radius r with the center at the origin. Yeah, 0, 0, because this is there's no like 2x squared plus 4y. No, okay, it's only x squared plus y squared. So it means that it's a circle. Yeah, so the center at the origin. Okay, with radius r. Let's say if you get x squared plus y squared equals to 4 squared. So the r here, the r is the radius. So the radius here is 4. Yeah. Is it 0 here? So we got 4, -4. All right. So this just okay as your knowledge. Now we look at, for example, if we transform from the Cartesian to polar equation, for example, if say we have this equation, x squared plus 2x equals to 3y. Okay, from Cartesian we have to transform it to polar, okay, equation. So just remember, your x equals to r cos theta. So you square it plus your 2x is r cos theta equals to 3. Your y is r sin theta. Okay, then you can expand this, so you get r squared cos squared theta equals to this part here. You can move to the other side of the equation. So you get 2r cos theta, this one is 3r sin theta. Okay, so you have 2 minus 2r, okay, minus 2 I put it in the back. So put this first, 3r sin theta minus 2r cos theta. Alright, now so here I can take out the common factor. You see the common factor r here. Alright, so I just take out, you might want to write another line. Okay. Okay, might want to write another line. I just want to save space here, okay. Now here this is r squared, and then we get r, then we can cancel off 1r, right? Or we can say divide the both side of the equation by r. Okay, divide r. Okay, divide by r. So here divide 1r means only 1r left. So this one is only 3 sin theta minus 2 cos theta. So your r is equals to 3 sin theta minus 2 cos theta over the cos square theta. Right, so here you can further simplify. As you see, there's a connection, right, between, or relation between sine cos. Okay, this one is cos and cos. Alright, so sine over cos, you get tangent. Tangent, then you still have 1 over cos, so which is the second theta. So this part here you get 3 tangent theta second theta, okay, minus, now this one here you get 1 over cos, okay, 1 over cos, because you cancel. Just separate it, you might want to add in another line. You can cancel. So here you get another second theta. Okay. Now if we are transforming from the polar equation to Cartesian, this is another the other way around, right? Okay, the previous example here, you are transforming from Cartesian to polar. Now, okay, look at the example, or I give you the just what happened here? Okay, polar equation to Cartesian equation. Now say r equals to a. Okay, where a is a constant. For example, your r equals to 5. So your r squared, you get 5 squared, which is 25. And then if you want to put in the Cartesian equation, recall x squared plus y squared equals to r squared. Yeah, so means that you can leave this as x squared plus y squared equals to 25. Okay, I'll give you another one. So if say it give you, put here, theta equals to pi over 4. Okay, so both sides, if we take the tangent for this angle, both sides, so we have tangent theta equals to tangent pi over 4. Okay. Now we know that tangent theta is y over x, right? Yeah. Okay, for the principal value, the angle will be opposite adjacent, right? And then when you evaluate tangent pi over 4, yeah, you get 1. So it means that here your y is equals to x. Okay, so you see there's a relationship. If they just give you the angle, yeah, and if you want to change it to the Cartesian equation, yeah, actually you can transform it, yeah, into x and y here. Yeah, if they only give you the r, okay, you can transform it to the x squared and the y squared here by using the equation x squared plus y squared equals r squared. Okay. Can another one, if say they give you r1 minus cos theta equals to 3. Okay, so they give you this. So what we can do here is, yeah, because what we can do here is, okay, you expand, so you get r minus r cos theta, which is equals to 3. Yeah, okay, and then your r equals to, this one you put it the other side, 3 plus r cos theta. Yeah, okay. Now, as we know that your r cos theta, okay, your r cos theta, which is equals to your x. All right. So that means this part is your x. All right. So this one is the 3 plus x. Okay. Or we put the x first. They are the same thing, right? Okay. X plus 3. So this is your r. Okay, but we do not want the r, correct or not? Yeah, we want it to be in x and y only. So what we do is we square. Okay, we square both sides of the equation. Okay, both sides of the equation. So we get r squared equals to x plus 3 squared. Because we know that this r squared is your x squared plus y squared. Okay, so not yet finished. We try to simplify this. Okay, since everything is in x and y already, right? Yeah, x and y. So here, what we do, we expand this, so you get r squared plus 3x plus 3x, so you get plus 6x plus 9. Okay, plus 9. And then here you see your x squared both sides. Yeah, you cancel, so your y squared equals to 6x plus 9. Yeah, and then your y will be equals to your square root 6x plus 9. Okay, so it means that from polar equation to Cartesian equation, okay, we can multiply by r, or we square both sides of the equation. Okay, we can multiply by r, or okay, we can square both sides of the equation. Okay, so that why? Because we want it to be like the example one. Okay, so we multiply by r, we get r squared. Yeah, because when we have r squared, we can change that to x squared plus y squared. Okay, so in order to have another r, okay, we either Either we multiply it or we square both sides. Okay, depends of the equation. All right. Okay. So it depends on the equation. So we have to look at the equation. Okay, so you just have to remember that, yeah, because you just have to remember that your x is equals to r cos theta whenever you transform, whether it's from polar to Cartesian or Cartesian to polar. So you just to remember, yeah, all this. So y is equals to your r sine theta, and where the r square equals to the x square plus y square. And because of this here, this is y over x, and we get the tangent theta, yeah, which is opposite end as it's y over x here. Okay, so that's how the all the things we learned yesterday. There's not much here, yeah. Okay, so do you have any question at the moment? I see some of you already posted your question for the tutorial. Do you have some more question, class? Any more? If no, then we look at whose question first. We'll look at Anson's question. 112, question 3. -2, 1, 3, 5. Now, Kenya, because okay, maybe you think later on you think about that, yeah. Let me show you this question. So what about this -2, yeah, then 1, 3, 5. Firstly, we find what is this 1, 3, 5, right? Okay, so 1, 3, 5. Somewhere here, right? Okay, so this is the 135 degree, yeah. Okay, just like I said, this one is your theta. So this is your theta. Okay, and then this is the point for negative. Okay, this is for the point, okay, for 2 and 1, 3, 5. So where is your -2 and 1, 3, 5? That will be this part here, because if we want the angle, we have to make it to the positive first. So this point here is your -2, 1, 3, 5. So Kenya, have I answered your question? Yeah, recall since the beginning of the lecture. Okay, so this part here is still negative, right? It means the other direction here, yeah, the negative part here. But class, you look at the angle to theta. So in order to get the angle, we have to find the positive r first. So just like back to our question just now, 112 question 3 here. Although we know this is -2 here, this part. This one here, okay, but we want the angle. So this part here, we know, yeah, we want the angle, so we have to get the +2 here first, yeah, as we know here. So we start from here to get the angle to theta. Okay, so back to this question, like what you discussed here, 111 question 7, yeah, is given -2, 1, 3, 5. So we have to find the angle for 1, 3, 5, +2 first, and then we know that, yeah, -2 is here. So have I answered your question, Kenya? Yeah, okay. So, right. So you clear your doubt already, huh? Okay. So you'll be able to work out this, yeah? Right? So just as long as you have the diagram. Okay, now back to Audrey's question. Okay, we have to find the rectangular. Okay, rectangular here means the Cartesian coordinate, yeah? Of each of the following points given is polar coordinate. So this is polar coordinate. Now as we know that, yeah, as we know the x equals to r cos theta, and then y equals to r sine theta, or wait here, y equals to r sine theta. Okay, so this is your r, right? Your r, your theta here. Okay, so your x will be equals to your r. Okay, so your r here is at 0.1 cos 5.2, yeah? Am I right? Yeah, 5.2. Yeah, so your y will be equals to your r at 0.1 sine, okay, 5.2. Now when they give this 5.2, so means what? Class, these are the angle in radian. Yeah, in radian. So we know that pi radian, so this is equals to 180 degrees. So you've got to change. Okay, change. So we have 5.2, this one is radian. So indicate, so how do we change it to degree? 5.2 over pi multiply 180. Yeah, so Audrey, what is the angle here? And then yeah, what is the angle here? Okay, so I believe you will be able to get the answer. Okay, but one more step, yeah, when you put it, you transform, yeah. So another line here, yeah, class, after you got your x and y value, please make sure you have another line here at 0.1, 5.2, map onto the Cartesian. This is polar, you map onto Cartesian, where you get your x here, your y here, yeah, okay. So maybe you calculate and you let me know what answer do you get here, yeah, for x. Yeah, Audrey? Yeah, can you, or maybe someone can help Chelsea, Audrey here? Yeah, you do it, we do it now. Yeah. Okay, you can round up to 2 decimal places here. Yeah, 2 decimal. Okay, so you get 3.79. Okay, you get your y negative 7.16. Okay, so put it here, yeah, class. Yeah, or you may want to show, yeah, because this is in radian. Okay, so you can use R to present it. All right, now here you get your x 3.79. Keep up to 2 decimal places. Yeah, this one you get negative 7.16. Then fill in here. Yeah, make sure you have this line here to indicate that this is the polar coordinate, and then they map onto this Cartesian coordinate. Okay, just make sure you have this. All right, now. Okay, next question. Okay, so we have to find the polar coordinates of each of the following points given is Cartesian coordinate. Okay, so this is Cartesian 1.3 and then negative 2.1. Okay, maybe Farah, think of this, yeah. So here your x equals to 1.3, and then your y is equals to the negative 2.1, correct? Now, recall that. How do you get the R? Farah, since you say you have only problem with the angle part, so what about the R here? How do you get the R?
R squared equals to x squared plus y squared.
Okay, so your R squared equals to your x squared plus y squared, correct? So you put in the, is that what you mean? X squared, your 1.3 squared plus negative 2.1 squared. Yeah, is that how you do?
Yeah.
Okay, so you get what answer do you get here for say okay, we'll do R directly. Yeah, so that will be 1.3 squared plus negative 2.1 squared. You add up together and you square root it. So what answer do you get for your R here?
2.47.
2.47, yeah? Okay, you've got your R. You means how do you get the data, right?
Yeah.
Okay, recall back just now since the beginning here. So how do we get the data here? Yeah. Tangent theta equals to y over x. Yeah. Okay. So tangent theta equals to y over x, because if you plot this on the diagram, okay, we will get the opposite and adjacent always. Yeah, because it's y and x. And then how do we get to the data? The data will be your arctan, your y over x. Yeah, so as we know here, your y here is negative 2.1, or maybe we just put in, yeah, or maybe you can put it on the diagram first and see where is the position. Okay, because we want the principal value of the data. Okay, you know what is principal value, right? Yeah, class. Or if you don't, not worry. Of course, you have to refer back, yeah, for the chapter for trigonometry here, and refer back for the principal value. Okay, or else here for this question, will 1.3. Okay, say your 1.3. Okay, give me a straight line. Okay, 1.3 here, and then your y is negative, because I want you to know which quadrant it belongs to. Because for tangent to be negative, it could be in a 2 quadrant. Okay, we are not quite sure. Correct, yeah, class. Okay, but we have to know here. Yeah, you can put in the point. Yeah, so don't worry about which quadrant it belongs to. So you put in the point. You see, x is 1.3. 1.3 here. 1.3, and then your y is negative 2.1. Say negative this down here, 2.1. Yeah, so that is the point 1.3, negative 2.1. So just draw a line here. Yeah, and then your tangent. Yeah, this one, okay, you know that, yeah, not yet finished, yeah, class. So this is we'll call the reference angle, because since they fall inside here in the fourth quadrant, and this part here, we know that we were getting the negative angle, right? So we call it the reference angle here. Okay, remember for the polar coordinates, our theta here will always measure from the positive x-axis. That means this is the theta. Okay, so now we get the reference angle first. In fact, yeah, this is the alpha. This is the beta. Okay, that will be the opposite. Okay, opposite and adjacent. So you see that, yeah, that will be your y over your x. Yeah, so you just put in the value 2.1 over 1.3. So what do you get here? Maybe
58.24.
58.24. Yeah, okay. So your data here, recall that, yeah, your data will be equals to 360 minus your reference angle. So 360 minus 58.24. So what do you get here?
301.76.
371.06.
301.76.
Okay, sorry, 301, yeah?
0.76.
It's not 371. We've only got 360. Alright, huh? It's less than 360. Okay, thank you.
0.76 teacher.
Oh, 76, huh? Wait, okay. What happened to my mind? If you want to leave in a negative angle like the question suggested, that is okay if you leave that negative angle, but make sure you have the negative and not just 58.24. You get what I mean? Yeah? So not yet finished, we have to put it in the polar form. So this is Cartesian form. Negative 2.1 that map onto the R, which is 2.47. Okay, so that will be 301.76. Okay, or if you want to put in negative, because we can have a negative value, right, for our angle. I think since the beginning of the here, did I put that down? Yeah, okay, the principal angle, we can have a positive, negative, or multiple. Okay, we can have positive, we can have a negative angle, okay, as well as the multiple. Okay, multiple here means you can put in like pi, radian, degree, and so on, or more than one round. Yeah, more than one circle, more than one round, like the one we practiced between 2 pi and 4 pi. Yeah. Okay, so that's what they mean by multiple, more than one round or more than one cycle. Okay, so just take note here, but you have to make sure that the theta here is the principal angle. Yeah, it's the principal angle. So you might want to check what is principal angle. Okay, they measure from the positive x-axis, yeah, or we call the polar axis if that is polar form. Okay, so no doubt you can put it in positive or negative, say 2.47, then just now our negative is 58, negative 58.24. Okay, or you can put it in the pi. Okay, maybe you can calculate what you get here. Yeah, in a radian. Okay, in a pi radian here. Okay, any more questions? Just now we discussed until Natalie question, right? Okay. Sorry, not Natalie, then Farah. Okay, now we look at Audrey's. Yeah, Audrey's got another question. 1, 2, 3, question 6. Okay, let's look at it. 1, 2, 3, question 6. Let me look at the question. Okay, the letter X and Y represent the rectangular, okay, or the Cartesian coordinate. Okay, write each equation using the polar coordinate. Okay, so question number 6 here. So we have 4x squared y equals to 1, right? Okay, now just think about this, yeah, class. We always use the formula where our x equals to r, yeah, cos theta, our y equals to r sin theta, and also our x squared plus y squared equals to r squared. Yeah. Now we want to change this to the polar form, right? Just trust back. Are you confused, yeah? Okay, transforming from Cartesian to polar. Okay, so you just substitute your x equal to r cos theta, y to r sin theta. Okay, and if there's any, look at the relationship here, yeah? Okay, to this question. Okay, so we want everything in r and theta. So Audrey, so what should we do here? Yeah, so firstly you see that this in x and y, right? We want to change it to r and theta. So we just substitute your x as r cos theta, but this is square, and your y is r multiply, yeah? Sin theta, and this is equals to 1. Okay, and what's next then? Yeah, you try to, this one is square, right? So 4r squared cos square theta, and then you have another r here, r sin theta, and this is equals to 1. Okay, right, so r multiply r, so you get 4r cubed, okay, cos square theta sin theta, multiply, yeah? Just multiply all together. This is equals to 1. Yeah, so your r cubed equals to 1 over 4 cos theta, cos square theta sin theta. Okay, now we can change as well here, right? Yeah, you look at, you can refer to the identity, yeah? In fact, we can change. Okay, so to change the double angle here, if you refer to the triangle identity, so your cos square theta, you have 1 plus cos 2 theta over 2, right? Yeah, or I think there is many way you can change, right? Okay, but if you only look at the one, okay, we can change it here. Yeah, your cos square theta, 1 plus cos 2 theta over 2. This is multiply sin theta. Yeah, so 2, 2, 2, 4. So you got 1 over, okay, 2 plus, this one multiply in first, yeah? Be careful with this, is multiply. So 2 plus 2 cos theta, yeah? And then you see that, yeah, plus the whole thing, you multiply sin theta. Am I right? Okay, don't worry. And then how do we simplify it? Yeah, if we expand, we have 2 sin theta plus 2 cos theta sin theta. Very happy if you see something like the 2 sin theta cos theta here. This part is the another identity, which is your sin 2 theta equals to 2 sin theta cos theta. This part here. Okay, so this is equals to your sin 2 theta. Okay, I just let me double check. Yeah? X squared y, so r squared cos squared r sin squared cos squared sin squared 1, then divide. Okay, just okay, cos squared theta we change to the identity 1 plus cos 2 theta over 2, and then we got 4 here, so 2, 2, then 2 plus 2 cos theta sin theta. Okay, multiply, so we get 2 sin theta plus 2 cos theta sin theta, and this part you can change. Alright, so there's many possibility of the answer. It depends on how you change the identity. Okay. question in class? Natalie done, Farah already, Audrey and Sun, Kenya. Okay. Yes, class. Any more question you want to discuss here? Now, when you up to, yeah, we're supposed to do up to which, yeah? We're supposed to do up to 1.2.5, yeah? 125. We're supposed to do up to 125. Next week, we'll look at the graph, the polar graph.